Okay, so now moving on, and we're still in section 10.3, but now we're talking about inverse matrices. So inverse matrices are two matrices that if you multiply them together, you will get an identity matrix for an answer. So I've got A represents the original matrix, A with a little -1 there. That means the inverse of matrix A. So matrix A and the inverse of matrix A, if they truly are inverses, you'll get an identity matrix for an answer. This I means it'll be either a 2 by 2, a 3 by 3, a 4 by 4, a 5 by 5, or whatever that is in that setup. Okay? Or if you reverse the order, it doesn't really matter, like which one's the inverse of which. If that's A and that's the inverse of A, they're also the inverse of each other. So the inverse of A times A should give you an identity matrix as well. Okay? So either way, you're going to get the identity matrix for an answer. So what I have here are two matrices that I already know are inverses. But I'm going to show you that if you suspect the two matrices are inverses, what you do is you multiply them together and you should get an identity matrix. So I'm going to multiply these together with you. And if we come up with an inverse or an identity matrix, then that would prove that these two matrices are inverses. So if you're trying to find an inverse and you're not sure if you found the correct inverse, the way to test it would be to do this. It would be to multiply them together. Okay? Later on, I'm going to show you how I came up with that matrix B to be the inverse of this one. But I'm going to go ahead and multiply them together. So 1, -1, -1, 2. And multiply that by 2, 1, 1, 1. So this is a 2 by 2. This is a 2 by 2. So it is possible to multiply them together. The answer I would get is going to be the remaining outer dimensions here. So I've got 2 and 2 here. So that means my answer is going to be a 2 by 2. So it's going to have 4 elements in it. So like we did the other day when we were multiplying matrices together, I'm going to take this row times this column. So the first element of this row and the first element of this column, 1 times 2 is 2. Second element of this row and the second element of this column, -1 and 1, multiply together to be -1. So when I take 2 plus -1, I get a 1 in that spot, which is what I was expecting, right? Take that same row times the second column now. So first element times first element, that's a 1. Second element times the second element in that column, that's a -1. -1 plus 1 is 0. Moving on to the second row now, because I need to get my second row answers there. So second row times the first column. -1 times 2 is -2. 2 times 1 is 2. When I add those together, I get a 0. Now when I take that row times the second column, -1 times 1 is -1, plus 2 times 1 is 2. When I add those together, I get a 1. This is indeed one of the identity matrices. It is the 2 by 2 that I showed you before. So I've just proven that those two matrices are indeed inverses of each other.